Hi, this is Professor Fernandez. We are going to work on lesson notes F in lesson 8. And let's take a look at what we are trying to solve here. This is a linear system, and we are trying to find the solution if it exists. So kind of like what happened in the previous video, this particular system is not one where you need to do a lot of apply a lot of fancy theory to solve. You can see right away that it is the same equation, just written out twice. So this is going to be one of the instances we had discussed in a previous video, where if you, for example, plot the graph of this first equation, which is y equals 1 minus x, the second equation, because it's exactly the same, its graph will be on top of the first graph. So we know before we solve anything that we're going to have an infinite number of solutions. Every single point is on both lines. But what I want to do is, again, illustrate how this shows up with augmented matrices and also illustrate what are called free parameters and how those arise. So I'm going to put this system into augmented matrix form. This is the third or so time we've done this in the course. So quick little reminder, I take the coefficients of all of these left-hand side expressions, and that becomes my coefficient matrix over here. And then I take the right-hand side, and that becomes my right-hand side vector B. Okay, so now I'm going to start the process of getting this to the form that I would ideally want it to be in to back out the solution. So I'm going to scroll up and remind you of what that form looks like. So this is what is over here. Okay, so this is ideally the form we want to get the augmented matrix into. So what we do is, as we've done in the previous videos, we work on the first column, try to do row operations to zero out everything but the first entry, the first row. And then we move over to the second column, and we try to zero out everything except for the entry in the second row. And then we keep going that way until we get to the last column, zero out everything except for the entry in the last row. If we're successful, then we can just read off the solution based off of what the remaining right-hand side numbers are. All right, so we're going to see in this example, which is why we're doing it, that this is not going to work. And that will show us again in augmented matrix form how a different type of solution shows up. Okay, so let's get the fun started here. So first thing I'm going to do is I'm going to say row 2 is replaced by row 2 minus row 1. And then what happens? I'm not changing the first row, so I will keep that the same. And I'm subtracting the first row from the second. So 1 minus 1, 0. 1 minus 1, 0. And 1 minus 1, 0. Okay, you can see now what I had foreshadowed about a minute ago. There's absolutely no way, I've achieved my objective in the first column, but there's absolutely no way to make this a 1 without changing this number. And that's okay, because now I have information that, again, we knew where this was heading. The second row is a row of zeros. So if I were to write out the linear equation that corresponds to, it's 0x plus 0y equals 0. In other words, 0 equals 0. So that's a true statement, sure, but it doesn't quite help us solve the system. And that's because, again, there are an infinite number of solutions. So at this point, there's nothing left for me to do for the augmented matrix. So I'm going to back out and write this in the equation, linear equation form. X plus y equals 1. Again, 1 and 1 are the coefficients that go here. Okay. So I have a choice. I'm going to make sort of the standard choice here. I'm going to solve for the variable whose coefficient is this, which is x. So I'm going to solve this equation for x to give me 1 minus y. Okay? So if I were to describe this solution, right, what would I say? I would say x is 1 minus y. And then y equals some variable, let's say a. An element of the set of real numbers. Okay, and once I've said that y equals a, I can go back up here and replace this with a. Okay, this is called a parametric form of the solution. Parametric because I have introduced a parameter. So if you give me an a value, then this will generate a solution. So example, let's say 0 is your favorite number. Okay, for a equals 0, x equals 1 minus 0, so that's 1. And then y equals a, in this case 0. Great, so that's a solution. Another example, let's say someone else's favorite number is 7. Fine. So x equals 1 minus 7, so that's negative 6. And then y equals a, so that's 7. Right? So you can see in this process how you can generate the infinite number of solutions, because you can pick whatever real number you want, and that will be the y value. And then the x value is 1 minus that real number. Okay, so that generates the infinite number of solutions. Last thing I'll do here is, just for notation's sake, right? If we go back to the system up there, x plus y equals 1, x plus y equals 1, this is the matrixed form of the system, 1, 1. And I'm going to say has the infinite number of solutions. I'm going to write this now in vector form. X equals 1 minus a and a, where a is in R. All right, so again, I just wanted you to see all of this written in full vector form. So that is the system in vector form, ax equals b. And this is the solution in vector form. So this is what we were talking about as x. This is what we were talking about as y. And then this is what tells you that you have an infinite number of solutions, because again, you can pick whatever real number you want and a solution will be generated.